Okay, so next thing we're going to look at flowcharts. Now before I even go there, so another just to correct my correction, this is in fact do. Yeah, so that was a mistake on my part. This is in fact do. So wow, that do. Okay, so now that we have this, right, so now that we have this, we're going to start looking at flowcharts. Flowcharts. In fact, before we do that, let's look at the structure of our algorithm. So structure. So far I've talked about the individual parts of our algorithm. So how do you write an algorithm? So say we want an algorithm that say prints let's say 0 up to 10, right? So we'd say algorithm, right? Then we're just going to say, we can give it a name, right? Let's say do something, right? Do something. Then we're going to say n. So n will be how many numbers are going to print, right? Okay. Then we can say okay. Then you always have to say what your input is. What are you taking in? In this case, we're saying our input for this array is an integer n. What is our output? What do we want this algorithm to do? Well, our output is the first, so the first n integers, right? So that's what we have there. All right, so we have this little bit of code here, right? Then what are we going to do next? Right? So then we can just make a simple for loop. We can say okay, for I being equal to 1 to n do, then you can just say print I, right? So say I there. We're gonna print I, and then we're just going to say end our for, and then we can end our algorithm. So what I was saying is that okay, we're going to have a simple for loop that prints from I up to n, and then we're just going to print out our I through each of these iterations. So it will print 1, 2, 3, 4 all the way up to n, right? So it's just a very simple algorithm. Now we have this type. Then now we have flowcharts. Flowcharts are a diagrammatic way of displaying our algorithm, right? Flowcharts. So everything we've discussed so far has a symbol when it comes to flowcharts. First of all, we're going to look at the oval there. The oval, what this signifies is start and stop, right? Then we have our rectangle there. Our rectangle is used for processing. So this could be adding a number, subtracting, whatever you want to do, whatever operation you want to do should be done within this. Then we have our, if I'm not mistaken, this is a rhombus. Yeah, whatever this shape is, but it's kind of slanted rectangle. This is used for input and output. So whenever we're saying read, so output, so whenever we're saying read, print, etc., we would use this. Then we have our decision box. Our decision box is similar to our if statement, right? So it does a yes, then it does a no, or a true, or a false, right? And what this is used to do is say, if we have some kind of condition in here, right? We enter a condition in here, and then it's similar to our if. It's similar to our if slash else. So it's similar to our if else, but it can also be used to represent a while loop, right? And also a for loop. So similar to this, but it can be used to represent this, right? Then we have our circle there, which is just used to connect to algorithm. So say your page, you can't fit your entire algorithm. You can add this and then go continue to the next page with another one. So it's just equal to I can just say continuation. In case you can't write your entire algorithm at a single point, you can just move it to the next thing. So now an example of what we've already covered, right? So we have this one over here. So how can we do that? Well, we're going to say, we can start it there, right? So we're going to say start, so you have to say start in there. Then now down here we're going to have our processing box, and then it's also important to just put like an arrow when connecting these two, so remember it's flow. So we're going to say integer n, right? So in this case we can set we can say n, so we can declare our integer n there, right? Or you can say in n, whatever, but you can just say n there. Then we're going to move on. Now how are we going to represent our for loop? Well, our for loop will be a decision box. So in fact we're going to declare, supposed to represent n, right? We're going to represent n there, comma, and we're going to say I, and then set I equal to 0. Remember, we're starting at I is equal to 0 for in our for loop. Then we're going to move down, then say okay. In our condition we're going to say I is less than or equal to n, right? Is it less than or equal to n, right? If that's a yes, inside our processing box, like that, we're just going to say, or inside our input output, I can say print I. Just going to print out I there, right? Then afterwards we're going to have another processing box here, this processing box here. Remember, we're supposed to increase I plus 1, so we're going to say I should then equal I plus 1. Then we're going to go back. So now the way we go back here, again, it's depending on how you want to do it, but then we can go in this direction. Just need to make sure that we feed this back into the original spot there, like so. We can do it like that. And then now, if it's a no, right? If we exceed, so remember, if we go back to our for loop, this will run as long as I is less than n. But then if we exceed, as a matter of fact, it's supposed to start at 1. If we exceed this, so if it's a no, what happens? We end our algorithm. So you can just say stop. So this is how we can move from our algorithm flowchart like this, and then we can even move backwards, right? So we can even move backwards. That's also possible. So when you start actually solving questions, or most of this will become extremely clear, because it's better to actually learn these things from solving real-world questions and me just saying, okay, this is what this is, etc., etc. So we're going to start solving questions in the next few videos.